The most recent addition to Thunder Power's expanding line of smart balancing chargers is a TP1430C. Now we have one on the bench, and we have a couple batteries and a couple of power supplies. We're going to go through the functionality and get you comfortable with the interface. But before we start playing around, I want to talk for a minute about high power chargers and get you comfortable with what you're going to require, what it's going to require on the input side. Most of us have 12-volt power supplies if we're using something that plugs into the wall. 12 volts is pretty common. 12 to 15 volt. A lot of them are variable. You may be able to dial it up towards 15 volts. But working in that 12 to 15 volt range, you're going to be able to charge up to a 7S pack. Once you go beyond 7S, it's going to require higher input voltage. So for example, an 8S or 9S pack is going to require up to 19.9 volts, 15 to 19.9 volts. So you're going to have to be 15 or greater on 7S to 9S. Then once you go beyond 9S packs into the 10S packs, which we have today as an example, that's 37 volts. 10S and up to 14, it's going to require 19.9 or 20 volts and higher. Now the example we're going to use is a 27 volt power supply. It actually puts out about 28 and dial down to about 21 volts. That's going to allow us to charge our 10S pack, but a lot of people don't have those kind of power supplies around, and they get a little pricey. When you get into a 27 volt power supply, you can be $250 pretty easy, especially if you're running around 40 amps, which if you've got a big battery pack that's 10S, you want as high amperage charge rate as possible based on what the battery will handle. So take that into consideration before you jump into the high power, high output batteries or chargers that may require a higher input voltage. Now, an easy way to get around that is to take two automotive batteries and put them in series, and now you've got 24 volts and you're fine. But if you're going to use an AC power supply, you may take a look at some of the specs before you make the plunge and realize it's now a $400 or $500 charging solution as opposed to just buying the charger. The other side is firmware updates. Make sure you do your firmware updates. The 1430 comes out of the box. It should come out of the box with the latest firmware version. Go out to the website and verify. When you first boot up the unit, you'll be able to see the firmware version. It's loaded down from the factory. But go out, make sure you pull down the utility and pull down the latest firmware update. You can go to thunderpowerrc.com and go to the support facts section. You'll see a downloads link. Go there, find your charger, the 1430, download the CUI interface software, and download also the latest firmware. That's going to allow you to load the CUI software interface, connect through a mini USB port to the charger, and then dump that binary in to update the firmware. Other than that, let's move on to the specs and get familiar with what the 1430 can do. The 1430 is a multi-chemistry balancing charger that will handle LiPo, lithium-ion, PB or lead, or sealed lead acid SLA, nickel cadmium, and nickel metal hydride. Now it'll balance up to a 14S lithium, so it has a balancing card or the balancing jack. You'll see the plate that it has for all the different connections up to a 14S lithium. But that's pretty monstrous when we look at doing our larger packs. Maximum charge power is 1,000 watts. That's what the charger is rated for. Now what that comes down to is your current. We're all curious about what the current rates are. That's 0.2 to 30 amps on the output side and 0.01 amp increments, which is nice so you can get dialed into those 1C charge rate cells, maybe some of your older packs, and you want to get right on the money as far as maximum charge rates. It's nice to have that 0.01 increment to be able to get tuned into exactly what your milliamp rating is. Now the input power, as we had mentioned, is 12 volts to 36 volts. So you've got a pretty wide range, and you're actually required to use some of those higher voltages for your higher S cells. This is a single output port on the charging side, so you're going to be able to charge one pack at a time. But the additional features on this charger that make it a little unique too, it has a USB interface for firmware updates. It also has 12 user programmable memories, so you can set up 12 different charge configurations or parameters, and that can be multi-chemistry, charge rates, whatever it may be, and then just quickly refer to those when you go through and charge your packs. It also has live data monitoring with internal pack resistant measurements. We're going to show you that too, so you can do a little bit of IR measurements while the cells are charging and see what your pack resistance is. So let's go ahead and get started. We'll jump down the bench and take a look at some of the capabilities of the TP1430C. Let's go ahead and get familiar with the layout of the 1430. The input is on the left-hand side. They give you pretty good sized leads, a 10 gauge wire with banana jacks on the end. Now they do include a couple of clips as well, so you can clamp onto a battery terminal and you can just plug the banana jack right into the end, or banana plug right into the end of those jacks. On the left-hand side is where the power comes in, and you also have the mini USB port as well, so you can connect to the PC and update the firmware. On the front panel, you have mode, enter, and then plus and minus, which represent up and down or moving forward or backward through the menuing system. You also have your 2 output ports on the front, which is single port, but 2 jacks for positive and negative. We went ahead and used one of the included cables. They give you cable sets, and just put our own Dean's Ultra connector on there. So we'll be using this interface for the test today, or for the setup. And on the right hand side, you have the balancing board connector. The balancing board itself is split into 2 halves. On the right hand side, you have the JST-XH connectors, and on the left hand side you have TP-FP. Now these all perform the same function, they just use different physical formats that you'll find on common batteries out there. In fact, we have a Life battery here that uses a JST-XH, and that's the white connector you'll commonly find on E-Flight batteries. You'll see them on Electrifly batteries, and a lot of Turnigys have the JST-XH connector as well. So depending on the manufacturer that you choose for your battery, you'll use the appropriate connector. There is one more, the Hyperion style connector, which you'll find out there. Not real common in the US, but it's a third format, so you may actually have that third. That third is a type of connector that's not included on the base board. But this will cover about 90% of the ones you're going to find here in the US. We're using the TP-FP connector, of course. This is a Thunder Power battery, the small black connector, and it labels on the board itself, printed right on the actual circuit board. They have the cell count, so 2 to 3S, and then you can go down through and find all of your different variations, 2 to 3S all the way up 6 to 8S, and then 6S plus 6S, and 7S, 7S. So depending on the combination that you have on your particular battery, you just follow the guide and plug in the balancing leads accordingly. We're going to go ahead and use our Dean's connector today. Like I said, we'll go ahead and plug in. We'll go ahead and power up. The first thing we're going to do is take a look at the power supply we'll be using for our first round of setup. This is a 12 to 15 volt power supply. This particular one is a variable rate power supply. It's adjustable from 9 to 15 volts. We went ahead and cranked it up to max. We'll go ahead and plug it in. I included a multimeter so we can get an idea of what our output voltage is directly from the power supply. So we see we're running 14.8 volts right now, which is well within the range of our 1430. We're going to go ahead and power up a 1430. Always power up the charger before you plug in a battery. So you always want to do that step first. We're going to go ahead and plug it in and go through some of the menuing. Now when I first boot this up, we're going to notice right here on the right hand side, it's going to flash the label of the charger and also the firmware version. So when you power yours up, right there you see V2.4. We've got the 2.4 version of firmware loaded on here. So always verify that you're running the right version on board after you do your update from the PC. I'm going to unplug these while we go through the navigation. Again, we have a mode button, an enter button, and a positive and negative or up and down. From the first boot up screen, you're going to see it's going to put you right into your memory 1 slot. We can go ahead and hit the enter button and go through all 12 of those different memories that are available. And to really go through and store those, all you do is make modifications and move out of them. It automatically stores the settings inside of them. So by default, it starts you off on memory slot 1. Now when you're looking at this first boot up screen, by hitting the mode button and cycling through, you have 3 root menu options. The first one we're looking at, which is our memory setting, which is really where we make all of our changes and our setups to whatever type of battery we're charging. We can also go into the setting data and the data view. Now the data view is when we have a battery connected, we want to look at the internal resistance. We want to look at each of the individual cell voltages as they're connected to our balancer, and a lot of the other data on live data once the actual cell is hooked up. The settings view is going to be tied to whatever memory you're setting on inside the memory view. So if we go back here, we're setting on what's been configured as a LiPo. If we wanted to change that up from here, we would actually hit enter and then go in, hit enter twice, and then go through the different types of cell chemistries. From we started off on LiPo, we can go to lithium iron phosphate or Life batteries, also referred to as A123s. I went too quick. It does time out, so you got to go back in. There we go. And there's our lead acid, PB, or sealed lead acid, our nickel metal hydride, and also our nickel cadmium. So when we go into that settings view, it's going to be relating or reflecting which battery chemistry we've got our memory setting on. So say, for example, I stored memory setting 1 is a LiPo, and we let this time out. Or we can just go right back to memory setting 2, and we change that to, I don't know, a Life. I'll go back to memory setting 3. We'll change that to a nickel metal hydride. And then we go back to our memory. and then we go down, you'll see it'll keep those settings. So memory 1 is a LiPo, 2 is a life now, and 3 is nickel metal hydride. If I go into the settings view on this memory setting, it's going to show me all the settings for nickel metal hydride. Likewise, if I go into the settings view from this life memory slot that I've chosen, it's going to show me all those settings and so on. Now additionally, when I'm sitting within each of these different memory slots, if I choose up or down, it's going to leave the chemistry as is, but it's going to change my actual function or the mode that the 1430 is sitting in. So right now it's sitting on charge. If I hit the plus, it's going to go to discharge, then cycle if you want to do a charge to discharge cycle, and then back to store. Now store is when you want to reduce your battery pack down to storage voltage, which on a lithium polymer is 3.85 volts per cell, roughly. So it does have an automatic storage setting on here, which is kind of convenient when you're putting things away for the winter. We're going to go back to our memory 1 settings. So let's go ahead and go into memory 1. I've got to get out of discharge here. There we go. Let me get back to charge. And then memory 1, I'll go back to memory 1. I'm in LiPo. And then I'm going to go ahead and go to my settings view so we get familiar with the most common batteries you're going to be charging with the 1430 are most likely going to be LiPos. So we'll get into there and take a look at it. If we hit our mode button, it's going to take us into setting data. We'll go ahead and move positive up through there. The first thing we come to is the LiPo charge end voltage is 4.2 volts per cell. By default, that is 4.2. You can change it by hitting the enter button and making modifications, but that's your industry standard, and chemistry standard is 4.2 max. Input power, low voltage cutoff is 10 volts, so you can adjust the low voltage cutoff inside the charger. Input current, a max of 40 amps. We can continue through here and we'll see cycle pause time. If we're doing a charge-to-discharge cycle on a nickel metal hydride or nickel cadmium, we can go through and adjust that time between charge to discharge or discharge to charge to give those cells a chance to settle out and rest and equalize before we go into the next process. Charge capacity limit, right now the default setup is 110% of the stated milliamp capacity of the battery you're charging. The most it'll allow it to charge is 110%. Now normally that doesn't mean it's going to charge up to 110% every time. That's just a safety cutoff to say that I'll only put in 110% of the stated capacity of the battery. Another safety feature is a safety timer. 250 minutes. So say you have this on a slow charge, in your slow charging the battery, at 250 minutes it's going to cut off. You can change that if you've got a specific application. You want to be able to take that down to a shorter period of time, but the most you can push that up to is 250 minutes. We're also going to look at temperature cutoff. Internal temperature cutoff is 167 degrees by default. There is no external temperature probes on this, so it's going to be looking at internal temperature to protect electronics. If you've got a real high charge rate going on, it'll cap it at 167 and turn off the charger for safety reasons. Going forward, key beep on or off. We can stop the beep that we hear when I press this button up or down. End beep duration is your finished charge or complete charge indicator. Right now it's 5 seconds. A 5-second tone will go off, and you know your charge is complete. The last setting is temperature unit. You can change from Fahrenheit to Celsius, and then we go back to setting data. Again, when we go to data view, that's going to be based on a battery connected. So let's go ahead and go back to our main screen, our first memory slot, and we'll connect the battery. The first one we're going to connect up is a 3-cell 1320 milliamp 11.1 volt battery. Now this is an older Thunder Power battery that'll only handle 1C charge rates, so we're going to show how to set up what would be a very common battery. We have a selection of batteries we can choose from, but this will be a good standard we can go by for our setup and configuration. The first thing I like to do is choose the battery I'm connecting. You really don't have to, because you're not going right into a charge process to connect it, but I'm going to go ahead and go through my settings here and set this up for the battery I have. LiPo charge, we're going to do a charge, so we'll leave it in charge mode. Our cell count is only 3 cells, so we want to take that to 3S, 11.1 volts. Our capacity is 1320, so we want to pull this down. Now, what you'll notice too is it automatically pulls the charge rate down along with it. One of the safety features of the 1430 is it by default keeps you in that 1C charge rate, so you're not charging at too high a rate for any given battery. Now naturally, as you get into some of the newer cell chemistry, and we have some here we can talk about, you're going to be able to charge at a much higher rate than 1C. So you can go through and manually override that. We have a 1320 milliamp, we've got 1320 milliamp in our capacity, and our 1C default charge rate is 1.32 amps, so everything looks good there. You can additionally go into the balancer and turn that off in the event that you don't want to use the balancer if you're using a chemistry that doesn't use the balancer, for example. But I leave it on by default because I want it to balance my cells all the time. So now that I've got my setup inside the 1430, I'm going to go ahead and connect it I always connect the balancing ports first, and I'm going to go into this 2 to 3S plug. And then I'm going to plug in my main lead and go ahead and plug in my battery. Now the cool thing we can do now is, since we've just connected our battery, we can jump back into our menu system here and take a look at that data view. And what we'll see is we do have our internal resistance. We can do an internal resistance check right now. Hold down the enter, and it will do an internal resistance check, 70 milliohm overall for the pack. If we go plus through that, it's going to give us the option to do a check on each of the cells. So now I see we've got 23 milliohm, roughly 22, 23 milliohm, a resistance on cells 1, 2, and 3. So again, as we continue through our data view, it gives us the ability to go to our individual cell voltage. Now if we continue to the plus button, you'll see it goes all the way up to our 14 cells. Since we only have a 3 cell here, it's registering cell 1, 2, and 3. And they're right on the money, 3.98, 3.97. This is right at storage voltage. So we're good. Our battery checks out okay. At least from this point, we have matching cell voltages, so it's okay to proceed to charge. What we'll do is we'll go back on our mode button. We'll go back to our first memory, LiPo Charge 3S, 1320 milliamp, 1.32 amp charge rate, and the balancer is on. All we do is, I'll kick on the fan on our power supply since we will be charging. And I'll go ahead and hold down the enter button, and it'll start the charge. It's going to do a battery check, and then it begins the charge process. Our main status screen is LiPo Charge. It's in the CC portion of the CCCV mode for termination methodology. On lithium cells, it uses a CCCV, constant current, constant voltage. So the first portion of the charge process goes into constant current, which dumps the current at 1.32 amps, our stated amperage. Once it gets up towards the top end of the cells and the charge voltage, the actual packed voltage begins to slow down, it's monitoring that process. It knows that the internal resistance is kicking up a little bit because you're at capacity. It'll switch over to CV mode, which will be constant voltage. So it'll look at maintaining a constant voltage as it continually and slowly increases up to maximum capacity, and it'll reduce the amperage accordingly so it doesn't overrun the battery itself. So, and that's a very crude way of explaining how CCCV is processed inside of a charger. But what you're going to see is this switch over, and your amperage begin to reduce as you get closer to that top pack voltage. So our total time, our whole process time, is listed up here in the upper right corner. We were 1 minute and 3 seconds into it. So far we've dumped 24 milliamps into the battery. So there's our general status screen. You can hit the plus during the charge process or the minus to take you through the different status screens while you're charging or discharging. Right now we've got 4.06, 07, and 07 volts on our 3 different cells. We can go through, and none of them are going to display since it's only a 3 cell. And then we go back to LiPo Charge temp peak voltage, 67 degrees internal, 12.1248 volts is our pack voltage peaked out right now. 1.37 minutes, or 1 minute 37 seconds or 40 seconds through the process. We continue up our input voltage. It does monitor 14.78483. We can see that in the data view as well. But we can see and verify off of our multimeter that that's accurate. And we go back to our standard charge status screen. So just move between while you're charging and you can monitor all that stuff. Now when you go back to your standard charge screen, you can hold down the enter button, and what that'll do is it'll escape you out of the charge process. It'll end it. And there you go. Now something else interesting, if we go ahead and start this charge again, we'll battery check. It'll be up and going. What we can also do is, while you're in the charge, if you want to override that standard C rating, hit the menu or hit the enter button, and it's going to take you right to your amperage. We can start cranking that up or down accordingly. So you can make adjustments to the base charge rate right there while you're charging. And we're going to find out later on when we do our high voltage packs, we're going to kind of need to do that to override the standard or the standard high-end charge rate. So let's go ahead and end this charge again and turn off our fan. So that's the basic function of a 7S or smaller pack on a 12 to 15 volt power supply. Now as we go through and we start looking at higher charge voltages, we're going to have to move over to our higher power setup. So let's go ahead and disconnect our battery, and we'll move into a higher pack. Now this is a 4400 milliamp 10S pack, so it's running 37 volts. Now this can handle, this is G6 cell chemistry from Thunder Power. This can handle up to an 8C charge rate, which is 35.2 amps on the input side. Now we know our charger is rated at 30 amps, but depending on our power supply's voltage, it's going to determine what the maximum amperage output is from the charger. So we're going to find out with us running less than 36 volts. We can't quite jam 30 amps into this battery, but we can get pretty darn close. So the first thing I'm going to do too is back away, then power off our 1430, switch over to our high power supply, and we'll get this out of the way. Now this power supply is very loud. It has a fan that runs constantly, and understandably, since it's putting out such high amperage. So now we have our power supply powered up. We're going to go ahead and put in our multimeter again to verify our actual voltage we're getting out of it. And what you'll see is, as I pull this in, what you see is things are going to jump up quite a bit from where we at with our 12 to 15 volt power supply. We're running 28.54 volts out of this particular power supply. As we plug in our 1430, same process. Always plug in before you plug in your battery. And immediately it's going to recognize that incoming voltage being much higher. So when we go through our menu and set up for our larger battery, it's going to give us some more options in terms of charge rate. So the first thing we're going to do is hook up our balancing ports. Now this particular one on this board, they break it out. This 10S pack has a group A, group B. So I'm going to take group A and put it in 1 through 6 on the 5S configuration. And then second group B is going to be on 6 through 11. So now we're hooked up to our balancing board. And we're going to go ahead and connect our main pack. Now you have an option here of either connecting from the Dean's connector. You get a lot of arc, a lot of static, there's a lot of inrush current there. I kind of like to pull the one lead, connect the Dean's, and then I notice there's a little less arcing coming off of my banana plug as opposed to my Dean, so it's a little less violent of a connection. But it's either way it works fine. This is just personal preference for me. I've noticed less arcing when I use the banana plug to plug in. So let's go back into our charger now that we're set up with a new setting and look at taking memory 1. It's going to be a LiPo charge, but we're now up in the 10S range. Now as I move over to my capacity, it's a 4400 milliamps. So again, you're going to see this amperage charge rate increase to 4.4 once I get up to 4400 milliamp. There we go, so we're 4.4 amp. Now we can go ahead and override that right now. This battery can take up to 35 amps. So we're gonna go ahead and pull our amperage up to what it'll allow us. Now based on the 28.54 volts coming in and 4400 milliamp with 10S, the charger by default is gonna cap us off probably right around 20 amps. There we go, 20 amps is our maximum in the memory setup screen. Now once we actually commit to the charge, we can override that and take the amperage even higher. We've got everything set up, we're ready to go. 28.54 volts on the input side, everything's connected properly. We can always verify our battery, which is a great idea to do with any lithium. Go into your data view, move up and verify that you've got voltage and the proper voltage on each one of those cells. So now we should go all the way up to our 10S, 1 through 4, 3.9392 looks good, 5 through 8, same thing, and then 9 and 10. So we're running good voltages, similar voltage. We're 0.1 volts or 0.01 volts off in most cases, which is well within the normal parameters. So we verified that our battery's good. If we want to check internal cell resistance, we can do that here as well. Hold down our enter key and it will flash the battery. There we go. And we're getting like 1 milliohm resistance, so we get very low resistance off of that battery pack. And you notice that between a 4-year-old cell technology and a current cell technology. So we'll go back to our memory. 1 LiPo charge 10S is set up 4400 milliamp, 20 amp BLC on, everything looks good. Now I'm very briefly going to fire this up. I do not have this in a charging bag, and I don't like charging at high amperage rates without some security or safety in place, but since we're going to do this demo, we'll just pull it down real quick. We're going to go ahead and commit to the charge, and then what I'm going to do is immediately go into the amperage field and crank that up to maximum, and you can see that we'll be able to go up to, should be around 25 amps with our input power supply. So let's hold down to commit. It checks the battery and starts the charge process, and we see our amperage climbing up. We're almost to peak in this battery. We're at 39.9, so when we get up to 20 amps, I'm going to go ahead and go in and take it up 21, 22, 23, 24, And there we go, 25 amps is the most it'll let me do with the incoming voltage we have. So I'm committed at 25 amps, and my battery's charging at 20 amps. I'm at 40 volts. It's already going to start pulling it down because it's past the constant currents going to the constant voltage side. So it's going to start pulling down my amperage incrementally all the way down to until my pack registers is full. So during this charge process, again, I can go through and check my individual pack or cell voltages. I can also go through and look at my temperature peaks. Now you notice I'm already up to 100 degrees Fahrenheit, 103 degrees Fahrenheit, so she's starting to get warm. Always verify and I just went ahead and killed that charge process. Always verify the temperature of the cables. When you do a high amperage charge rate like that, like I can already feel these wires getting a little bit warm, not hot, but warm. My charger started getting warm. I felt my fans were putting out a little bit of heat in the back. My leads coming off my power supply were definitely increasing in temperature a little bit. But my Dean's connector was staying cool. My battery wires feel pretty good. They're nice and cool. A little bit warmer up here near the jack. That's normal. These particular wires are rated at 200 degrees Celsius. Now you never want to let them get that hot, but that's normal to expect a little bit of warmth to be generated when you're pushing 25 amps across the charge process. So that's really the only thing you need to keep in mind. Again, of course, the series or the sequence is always disconnect your battery, then power down your charger. So we'll go ahead and pull our main lead pack or pack lead, pull our balancing leads, and then go ahead and power off our power supply once those caps bleed out. And there we go. And we're disconnected. As I had mentioned, make sure when you're doing a charge, any charge, no matter how small or insignificant the battery seems, this 2-cell, 2,000 milliamp battery, or all the way up to this 10S pack, always charge in a charging bag. In fact, Thunder Power has some very small compact charging bags now. Instead of the old larger rubbery bags, they have some small ones that are pretty convenient for most of their battery sizes. You know, the 2700 milliamps, the 2250 milliamp packs that you typically see in park flyers, they fit in there extremely well. And it just makes that added level of safety. Don't charge unattended, but it does give you the confidence of being able to be in the same room, work on some other stuff, and you've got some level of security. I also use a fire-safe security box when I'm doing large packs because a lot of times they don't fit very well. I'll use an old fire-safe security box, and I'll go ahead and pass the leads to the end of it to connect it and let it charge up that way as well. So just be mindful and safe. There's a lot of energy potential here. We can discharge at 396 amps alone on this battery. So if you think of it just from a power potential perspective, that's going to be a very hot fire if something goes wrong with this battery pack that could easily take down a house or injure you or kill you even. So just be mindful, be careful, and be sensible when you're using high power chargers and high power battery packs. Well, that wraps up our overview of the TP1430C from Thunder Power. If you'd like to learn more about batteries and charging in general, you can go to our website at tubefly.com and click on the knowledge base link at the top. For mobile users, you can go to rcflightsource.com and download our mobile app and take our workshop clinics on the go. If you have any specific questions regarding the TP1430C that haven't been answered in this brief overview, I recommend you go to the Thunder Power website at thunderpowerrc.com and look under the Support Facts section and see if the answer to your question resides there. Otherwise, double check the manual. If you're still stumped, you can hit the Ask To icon on our website and send us a message, and we'll do our best to either answer your question or send you in the right direction.